Okay, cool. So hi all. Hi everyone. My name is Jun Hong. Yep. So this is kind of really an impulsive and random decision that I came to. So basically, I was quite bored, and I just I was just like, oh, why not just try out some MF paper and see whether I can try it. And then after trying, I realized that I can still do most of them. So I decided, might as well just make some videos for you guys. Okay. Yep. So this video is entirely free. It's just for whoever who is interested in MF, this is the MRSM paper 1 of 2022. And yet today I'll be going through this paper with y'all, and then basically I'll just kind of like share how I usually tackle the question, and I hope some of the techniques might be beneficial to you. Okay, cool. So I think yes, without further ado, let us get started. So yes, let's look at the first question. So this is a curve, obviously, and then you have two variables here, and it says that these variables x and y, so you have to check whether or not the x-axis and y-axis does represent x and y. So as you can see here, this one is y, correct, this one is x, correct. So why do we always do this? Because sometimes the question might give us another random variable. Let's say it could be y squared, y over 2, or anything like that, because in this chapter is about transforming graph from non-linear to linear or to any other shape. So we can always manipulate, we can always play with the x-axis and y-axis and to make the graph shape different. That's why it's very important to look at the axis first before anything. So now after checking, you know that this is actually x and y, and this is a curve, this is an equation, these are coordinate. So when you are given a curve equation and then you are given a coordinate, it's very simple. You just have to sub value. Okay, no matter what, whenever you see a curve, whenever you see an equation and there's coordinate given, you have to know that this coordinate must fit into the equation itself. So obviously this is x, this is y, this is x, this is y. So obviously, if you find the equation, you can see that you will get two equations because there are two coordinate, two equations. So you will have two equations, each containing P and Q. And now you can solve for P and Q as requested by question 1A. Okay, cool. So now let's just find the equation. So it's simple. For let me change the color maybe. Okay, so yeah, let's take the first example, this coordinate. So 4 squared, 4 is y, so 4 squared equal to p over 2 negative 11 plus q. Another equation, 2 squared equals to p over 2 negative 5 plus q. Now maybe let's try to simplify the equation a bit. So something like this. Okay, cool. So now you have two simultaneous, you kind of have a system of equation in two variables and it's simultaneous and then it's all linear. It's very simple to solve, okay? Yep. So in my suggestion, as you can see here, since both of the equation, you just don't touch anything, don't move it around because it might, for example, some people might tend to move the 2 or close to or. It's okay to do that. It's just that it's not really necessary when you have equation that is actually set. And as you can see, you can find some kind of similarity between these two equations where you have an integer here, and then p here, and then q here. And also, most importantly is that the q and q is the same value, same coefficient. No 2q, no 3q, it's just q and q. So obviously you can cancel out the q by simply subtracting the both equation. You have q in one equation, q in another equation, so q minus q, nothing. Okay, left with nothing. So let's try to say this is equation 1, this is equation 2. So if we use equation 1 minus equation 2, you'll get 16 minus 4. And then equals to negative 11p over 2 minus negative and then q minus q equals to 0. Okay, cool. So now let's solve for p. So this one, if you simplify, where's my calculator? So if you simplify, negative 11 divided by 2 plus 5 over 2 equals to negative 3p. This is 12. Okay, so 12 equals to negative 3p, and I think from here onward it should be the very basic math. So p equal to negative 4, and then q, yes, you just try to sub back the value and then you see what is q. So you can do something like this, and then you plug in the negative 4 here, and then you see what will q turn out to. So q plus this, and then q will be negative 6. Okay, yep, so this should be the final answer. Let me just cross check with the schema. With the marking scheme, yep, it's correct. So p equal to negative 4, q equal to negative 6. Okay, yep. Now the next thing, you need to sketch the linear graph, and it says it's a linear graph, so just bear in mind that your graph, of course, it must be a straight line. Okay, yep. So now looking at this straight line graph, it already gives, this question is just too good. It already gave you what is the variable, it's y squared and x. So just put a graph like this and then put y squared and x. Because it's given by the question y squared and x. And as you can see here, why do we do y squared and x? Because if we do y, it will become a curve, obviously, because it's quadratic. But if you do y squared, then this entire thing become your so-called big y. So you will simplify the entire equation down to a linear equation, okay? And that's why you can make a linear graph. So let's say now we want to do this, and as you can see, let's compare the equation. Y equals to mx plus c. So you can see here, q corresponds to c. So your y-intercept is your q. Let me repeat. Your y-intercept is your q, right? So that's to say q is -6, right? So over here, your q, which is -6, it should be your y-intercept, okay? Yep. And then the graph, it's showing negative gradient because m is corresponding to p over 2. Okay, m is corresponding to p over 2. That's to say the graph is going downward because our p here is a negative value. So positive graph, positive gradient, negative graph, negative gradient. So in this case, it should be negative. Okay, yeah, I think that's what required by the scheme itself. But you know, if you want to make it perfect, I would suggest me myself to add this intercept here. It should be I'm not sure what, but -1.5, I guess. Just do the formula and you can check. Okay, yep. And then if even better, you can also include these two plotted point into your new graph. So for example, now the new graph, it will become because it's now y squared against x mass, so it will become -11 is still -11 because it's still x, but then this 4 will become y squared, so it will become 16. So somewhere in your graph, when you have -11, and it should correspond to 16, something like that. Let's say today the question, it gives like maybe 3 or 4 marks to this graph sketching, to the linear graph sketching, then you can try adding a lot more details into this graph. Okay, so what I would suggest, of course, on the axis, and then the intercept, and then the initial point. How are they now repositioned in this new linear graph? Okay, yep, that's all for this question. Okay, cool. Wait, is that all? I guess so. Okay, let's look into the next question. This one should be quite simple, just quadratic, right? So let's do a little bit of recap. So in quadratic, we say sum of root equal to -b over a. What is b? What is a? Yes, we follow this equation. Just c, okay, plus c. Yes. Okay, this is the equation, and then the product of root. This is XOR. This is POR. The product of root should correspond to c over a, which is your divided by this. Okay, so now look into this equation, x squared plus mx minus 3, and as we can see here, a is 1 because there's nothing in front. Nothing equals to 1. Don't tell me 0, please. Yeah, nothing equals to 1. M is your b, -3 is your c. Okay, cool. Now it says that the roots of the equation is 2 alpha and 2 beta. So that's to say your sum of root, let me just kind of clear this out. So that's to say your sum of root, So that's to say your sum of roots here. Yep. So that's to say 2 alpha plus 2 beta, your sum of root equals to 2 alpha plus 2 beta will be equal to -b over a, which is -m. Okay, that's that. Secondly, product of root, it will be equal to 2 alpha times 2 beta, it will equal to 4 alpha beta, which gives us c over a, which in this case, it will be -3 over 1, so -3 lah. Okay, yep. So that's it. That's our basic information. And now you want us to find the value of m if a plus b is -2. So now, as you can see, these two equations, which equation involve m? Obviously, it's the first equation. There's an m here. So we are obviously focusing into our SOR, sum of root, because that's where m is involved. And that's what question 1. And then the next thing is that you have to try to extract a plus b out of the equation so that you can just sub -2 into that so-called bracket. And then you can simplify the equation down. Okay, yep, cool. So as you can see here, the equation simplified to something like this. So 2 alpha plus 2 beta equals to -m. Now, doing some math, you know that this is actually 2 bracket alpha plus beta equal to -m, and you know that alpha plus beta is actually -2. So just sub the value into, so it becomes like this. So m equals to 4. Let me check. Yeah, m equals to 4. Okay, yep. And the next thing, you want to form a quadratic equation with roots A and B. So now you have root A and B. Again, how do we form a quadratic equation? We use the same method, but we go backwards. So we have to first find what is sum of root. It's A plus B, and we know that it's already negative B plus A, which is negative 2. This was given like in the last question. Secondly, we need to find product of root, which is alpha beta, which we actually don't know what is the value, but we know it's negative C over A. Okay, so this is the information you have. Now, you know what's missing? Yes, what's missing is the product of root, which is C over A. So we have to find what is C over A here. So how do we find the alpha beta here? Yes, as you can see here, we actually have another equation over here that we actually didn't use in the previous question. So as you can see here, it gives 4 alpha beta equals to negative 3. So from here, we can know that, of course, we can't like actually identify how much is beta, how much is alpha, but we can identify, we can find that alpha beta is equal to, yes, this gives alpha beta is equal to negative 3 over 4. So that's to say my negative C over A also negative 3 over 4. Okay, yep, so let's construct our equation a squared plus bx plus c equals to 0. Since now we don't have exact value of A and B and C, but we have over A, right? So how do you make this equation into over A? So you divide everything by A. So by A, x squared plus b over ax plus c over A equals to 0. Okay, I mean, of course, 0 divided by A is still 0. Yep, and then now we just sub the value in. So negative b over A equals to negative 2. So b over A equals to 2. That's it. So plus 2x. Negative c over A equals to negative 3 over 4. So c over A equals to 3 over 4. So like this. Oh wait, there's a negative y. Something's wrong, I guess. Alpha beta equals to what's wrong? Why there's a negative in the answer? Alpha beta. Oh, sorry, there's no negative in this. Okay, there's no negative here, so it should be c over a straight away. It becomes negative 3 over 4, so negative 3 over 4. Okay, this is the final answer given by the marking scheme. Of course, again, I would suggest a quadratic equation should not contain any non-integer. So in this case, you can just kindly remove the over 4, the denominator, because it's kind of annoying. So you can multiply the entire equation with 4. So something like this. Okay, my suggested answer. Okay, yeah, that's it for this question. Okay, cool. Question 3. So this again 2 graphs, and then determine which graph represent a function. So yes, always remember. The thing about function is that you have, function is like a magical spell. You apply the spell onto some certain number, it gives you another number. So it's kind of like a machine. You put the number into the machine and it gives you output. It output another different number, or maybe same number, whatever. It output another number. And this number is definitely specific. So I can't just put in one number, I get 2 numbers back, because that's not how a machine would work. That's not how this function would work. But then I can put in 2 different numbers, but I get the same number. I put in 2, I also get 4 as a result. I put in 3 maybe, I also get 4 as a result. That is okay. So that's the same function. You can have a lot of different input, but all of them must give only one output for each input. Okay, only one output for each input. So that's to say you can be 1-to-1 relation. It can also be many to one relation. Okay, yep. So in this case, determine which graph represents a function. So you can see each you ask which graph, right? Okay, so let's say this will be your object. No, in object this will be image. So that's to say this is mapping onto this. So as you can see here, each of the value, it corresponds to only one y. Each x matches with with one y value. So like this, one value. So it's all valid because all of the object has only one image. All of the x has only one value of output, which is y, which is fx. Okay, but over here, as you can see, one value of x can actually give you one value of x can actually give you 2 value of y. Let's say we take this 3. 3 correspond to this value, but at the same time it also corresponds to another value. This is why the confusion came in, because one x value have 2 y values, so that's why it's not valid. Okay, yep. Let me just double check the scheme. So Yep, so the answer is y equals to fx, this one, because, no, the thing is that I'm looking at this because it says x equals to gy, which suggests that y is my object, x is my image, right? I hope I'm not like kind of like, how to say, falling behind the syllabus, but from what I can interpret, yeah, so as you can see from this equation itself, y should be the object and x should be the image. So if we are looking at graph, one y value should have one x value. That's to say, one object has one image. So every of the y value is corresponding to one x value, which I think it's quite okay. I mean, there's nothing wrong with this, apparently. Okay, yep. So I'm not sure is it a question error or something. Feel free to correct me if you know the actual answer. Okay, yeah. But anyway, from my perspective, both of the graphs should be a function, provided that this equation holds true, such that y is my object, x is my image. If you do the inverse, if you do the other way around, y equal to gx, then this is definitely not a function because it's mapping one value of x, one object to different image. Okay, like you input one thing but you can get two different output, something like that. Okay, yep. So in this case, I would suggest, anyway, you know, since question asked for only one graph, which graph, not which graph, tentukan graph bukan graph. So by right, it should be only one answer. And I mean, in this case, it's very obvious, like very obvious that it should be the straight line graph. So the answer, we still go for y equals to fx. Okay, what are the example of answer explanation you can give? You can say because it's a one-to-one relation, because something I keep mentioning, because one object has one image. Or you can just perform a vertical line test, which is something like this, and you make sure that the vertical line cannot cut through two values. Okay, yeah, two y values. So in this case, if we are assuming that x is my image, like we are kind of like, you know, we are kind of like inverting the entire graph. So we kind of viewing like, you know, the ballet. So this should become your y-axis, this should become x-axis. So it will become like the vertical line test is now actually horizontal because your x and y is kind of like swapped. Okay, you know, your image object is kind of like swapped position. So it should be like this. As you can see, if we perform a vertical line test, the so-called vertical line test, it looks horizontal simply because your x and y is now different. It's now swapped. They are no longer the common position. Okay, that's why it's inverted. But anyway, it actually passed the vertical line test based on this equation. But anyway, answer does not suggest that it's a function. So maybe some part of it went wrong, some part of my understanding, but yeah, feel free to correct me. But anyway, for the answer, you should go for the straight line. So one object has one image because it passed the vertical line test. So now next one, state the domain. What is the domain? Domain is your x, your object. So as you can see here, your function go from 0 to 5. That's it. So 0 to 5. Okay, yep. Next one, the range is your y. So your y goes from 6 to -4, 6 to -4. So fx goes from 6 to -4. Finally, the function notation. This one is quite simple actually. You just make sure you write it clearly. It's a function. For example, fx equals to, yeah. Okay, so now the hard part is what is a function here? Okay, what is a function here? First of all, we know that it's a straight line. Straight line follow what equation? It follows equation y equals to mx plus c, right? Y equals to mx plus c. So we need y, of course, it's just y is a variable, x also a variable, but we need the m and we need the c. We need gradient and y-intercept. So in this formula, we can see that we already have the y-intercept is just -4. But we need the m, the gradient. So how do we find gradient? Yes, the formula is y minus y, x minus x. So let's say we just take 2 points here, y minus x, x minus y. So 6 minus -4 divided by 5 minus 0. It will give me 2. If you don't want to do like this, there's also another way. We call this negative y-intercept over x-intercept. So it will be negative of -4 over 2. 2 is my x-intercept. So it will also give 2. No matter how, it will reach the conclusion that gradient is 2. So plug into this equation, y equal to gradient and equals to 2, x plus c. What is my x-intercept? Sorry, y-intercept. Yes, according to this graph, it's -4. So your fx should equal to 2x minus 4. Okay, yep. If you want to do another way, which is something more high class, it is written like this. I usually don't do this because it's just weird to write an arrow but yeah, just make sure you don't mix them around. If you use a bracket here, you must make it follow with an equal sign. If you use the so-called, okay, the so-called, what is this called? I'm not sure what is this called in English, but yeah, if you use a so-called how, then you should follow by an arrow. Okay, yep. So that's it for this question. Okay, 3, 2, 1.